So that was us mixing two compounds in dichloromethane.
Okay, so let's talk about some of the mechanisms that are occurring when you do liquid-liquid filtration using a separatory funnel. So in the example that we're going to show you today, we have benzoic acid and phenol. And these two compounds are going to be in a solution of dichloromethane. But these aren't the only two compounds we have to consider, because benzoic acid could also exist as its conjugate base, which would be the benzoate ion, and phenol can also exist in the deprotonated form of the phenolate ion. And so before we get started, we need some information about all of these compounds, and the most important bit would be the pKa. So benzoic acid and the benzoate ion have a pKa of 4.2, and phenol and phenolate ion have a pKa of 10.0. Now we're going to use this information to help us separate out these two compounds. Alright, let's look at the two equilibrium that are going to be occurring in our solution. We'll have the equilibrium between benzoic acid and its conjugate base, the benzoate ion, and another equilibrium between phenol and the phenolate ion. Now, where these equilibrium lie is going to depend on the pKa of the solution in which they're in. So, when they're in dichloromethane, these compounds would have no reason to be deprotonated. So, we will see benzoic acid and phenol, which are both somewhat nonpolar molecules, which is why they're soluble in dichloromethane, which is also somewhat nonpolar. Okay, now if we want to separate these compounds, we're going to need to make one soluble in water and one insoluble in water. And we do this by adding a base that can deprotonate one, but not both of these compounds. So let's pick a base. How about sodium hydroxide, which has a pKa of 15.7. What would happen if we added sodium hydroxide to the solution containing these two compounds? Well, since 15.7 is a greater pKa than the pKa for both benzoic acid and phenol, it would be able to deprotonate both compounds. Thus, they would both exist in the deprotonated form as the benzoate ion and the phenolate ion. Now, if this were the case, both would exist in ion form, and ions are soluble in water. So, both of the compounds would exist in the aqueous layer. They would be soluble in water. This wouldn't really help us because we still have two compounds that we can't separate. Now imagine if we used a weaker base. So sodium carbonate, something that has a pKa of 6.5. Now since this pKa lies in between the pKa of benzoic acid and phenol, one of them, the benzoic acid, will be deprotonated by this weak base. But the other one, phenol, will not be deprotonated. Thus, the phenol will exist in the organic layer, seeing as it is still insoluble in the polar water, and the benzoate ion will exist in the aqueous layer, as it is an ion and will be soluble in water. This leaves the two compounds separated, and we can use a separatory funnel to separate them and then analyze.
So the first step that we're going to do is take our solution of dichloromethane with the two compounds and pour it into the separatory filter. Then we're going to add our base. That label is incorrect. That is actually sodium carbonate. When we're adding this base, as we went over in the PowerPoint slides, it is deprotonating one of our two compounds, which will separate them into two distinct layers. Now you need to mix it around, but be sure to let out pressure. You do this by pointing the nozzle away from you and into the hood, then opening it, and the pressure will be released. Once that's done, you can make sure it's securely attached. As you can see, there's two distinct layers, the top being the aqueous layer and the bottom being the dichloromethane layer. Now take 3 jars and label them, and then you can begin to separate. So twist it until the liquid starts pouring out, Make sure that you stop just before the bottom layer is completely drained. Then once you have the bottom layer, the organic layer, which is in dichloromethane, you can take it and rotovap it and isolate it and do analysis on that. And then once you've separated the other layers, you could reprotonate the ion in the aqueous layer and do analysis on that. As a last point, we want to make sure you don't do things like point it at someone when you're draining the pressure. That could be dangerous. Look at that. Adi is obviously hurt. Don't touch the liquid like that. That's stupid. And be sure to use your PPE.